Hey everybody, it's Joe G from the new 8-Bit Heroes. Thanks for checking out this video about NES Maker, the toolset that we built to create actual hardware-playable cartridge-based NES games without ever having to write a line of code. Hey everybody, it is Joe G with the new 8-Bit Heroes with another NES Maker update. Today I want to talk about input management. This has been one of the hardest things to sort of conceptualize as we've tried to turn the engine we built for Mystic Searches into something that would allow you to create your own game. It wasn't that bad for level editing, and it wasn't that bad for creating modular-based AI and things like this. But actually controlling what you wanted to do with the input conceptually within all the constraints of the NES was one that was kind of tricky, and it's still definitely a work in progress. However, I wanted to show you not only how it works with existing scripts and being able to attach them to inputs, but also how to dig into the assembly language for those of you who want to take it to that level and be able to start coding your own scripts and things like that. So this video might get a little bit complex when we start to look at the ASM. It's really going to be simple ASM, but what I don't want you guys to worry about is I don't want you to think you have to write ASM in order to get this to work. You have to write code. No, there's going to be a whole bunch of code that is provided for you that you're going to be able to pick and choose and assign and things like that. But I want to show you how it is possible with this video with just writing a little bit of assembly code to demonstrate the point. So I'm going to show all those things, and today we have as a guest Sydney Hunter, who's a character in the upcoming series of games by CollectorVision. CollectorVision has been doing this a long time. They've been making games for all kinds of classic consoles. Their newest is Sydney Hunter for the Super Nintendo. The fact that they are big supporters of the project is super humbling because they have been doing it for so long and they know what goes into this, and they think that this is a worthy pursuit, which is just super humbling and validating for us. And they have allowed us use of their main character to sort of show off this feature video. So, without further ado, this is our character Sydney Hunter. This is his tile set for the Mayan ruin that he will be exploring, and we're going to do really simple input management to demonstrate the point with this. Otherwise, I could go on for hours and hours about this. What I did was I used our pixel editor to create our player object. If you guys didn't see the pixel editor video, check out the video number 7. Which showed off the use of the pixel editor and how we were able to take a bitmap like this and turn it into something that we can actually use. I made a hero. I gave him 2 different animations, which is going to become important later. Default, which is kind of walk, and run, which is him actually running, and set up his actions so that he's got 2 actions. One is his idle and one is his run, and running has an animation, and idle is just him standing still. Give him a bounding box, all this stuff. All this stuff is covered in other tutorial videos in the series, so definitely look back through those. Today we're going to be able to talk. We're going to talk about how to actually make him move without depending on the code that was already there, with actually writing our own and applying our own code to different inputs and things like that. So I've also went ahead and created a bunch of assets and a screen for him to play on. Let's make that a little bit bigger so you can see the screen for him to play on. Right now, though, I've taken away all of the input. There is no input in the game. Now, there's still well over 100,000 lines of code that are running to do things like drawing and memory management and all kinds of stuff. But right now, there's absolutely no input. And in order to demonstrate this, I'm going to export and test this and open it in FCEUX emulator, because FCEUX emulator has a little graphic that you can bring up that shows you what buttons are being pressed. So let me export and test. I'm going to open that ROM up in the FCEUX emulator. And here's the ROM. The problem is none of my keys do anything. I think I should press start if you look down here, and it should start the game, but it doesn't do anything. I've taken all the input code away. All right, so the first thing we have to do is get it from this screen to the game screen when I press the start button. we're going to use the input editor in order to do that. And here's what we need to do. And there's still one more step that we have to do first. But I want to say that if I am on the start screen, if I'm in that game state, and I press the start button, not really affecting an object, just sort of the whole game. So I'm going to choose null. And I'm going to choose the script that tells the game to start. Now, that might mean different things to different people. Maybe you go to a registration screen. Maybe you have to enter your name or a password, or maybe it goes to a story, some kind of cutscene. Maybe it plays some music. Maybe your game isn't even really a game, so this totally changes what this means or how you get from the start screen to the next screen or whatever. All right. For this, what we have is we actually have a script already that exists. So I'm going to go to Code Scripts, and I'm going to. These are all the codes that currently are part of this engine. And I have one called Start Game. I can add it to my project, and now you can see it shows up in the hierarchy. In fact, if I click on it, I see the assembly. Not only do I see the assembly, I can actually write. This is a very, very, very simple code editor, and I could save it and save changes. And we're going to actually use this to make simple assembly codes today. Or if I double click on it, it opens it up in. It opens it up in my chosen text editor, which I use Notepad++. So if I just like looking at it there, double clicking on it will open it in my default. Or if I just need to do a spot check, clicking on it will show it here. The part I'm really interested in is this part right here. This is the part that basically tells it to start a fade, and when it comes up from the fade, to enter into the main game state. And that's how I transition from my start screen to the main game in this engine. So I need to run the start game code when I press the start button. When I'm on the start screen, when I press the start button, not really talking about any object, so I'll use null, I'm going to run the start game script. And this is where all the input scripts in your game are going to show up, so you can reference them. When I press start, it's going to run the start game script. Let's test that. Okay, and again, if you look down here, you can see the inputs. I'm pressing up, I'm pressing right, down, BA. But if I press start, there we go. It runs the start game script, which launches me into the main game. Still using the Troll Burner HUD. I haven't changed that yet, but you can see. Now, I want this guy to move. But like I said, I've taken away all of the input scripts, so I can show you how we can add them. Also, to note, I'm pressing the start button, but it's not trying to change. It's not trying to change game state because that was only good for the game state that I was in. I'm in a new game state. I don't want start to start the game anymore, so that only worked in the game state that I was in. All right. Well, now obviously we want Sydney Hunter to start moving around the screen. So we know that we're going to go to main game. And we're going to say, okay, when I do something to the left and right, there's something that's going to happen here. I'm going to get some kind of script that's going to make him move. Now we're going to have very extensive movement scripts that handle collision detection and do all kinds of things that you won't want to have to code yourself unless you wanted to. But for right today, I want to actually write a movement script. I'm just going to use assembly to make a move, and it's not even going to exist yet. So I'm going to go to Code Scripts, go to Movement Scripts, and I just made a simple move right script, and it's just empty. All it does is when it hits this, it returns back to the place in code. It doesn't actually do anything right now. All I'm going to have it do is I'm going to have it increase the X value of whatever object is calling it. So I'm going to tell it to increase this part right here, this first part. There's a bunch of bytes that are labeled like this that are basically, you can think about them as variables for the object. All right, each object has an X value, and each object has a Y value that determines where they're drawn on the screen. Each object has health. Each object has speed. Each object has all these things This X right here, that doesn't mean where it is in the screen. This X right here lets it know what object we're talking about. So if this happens to be a 7, it's changing the position of object 7. If this is a 3, it's changing the position of object 3. We're saying whatever object is loaded into the game at this time right now, we want to increase its X, and that's what this script does. The script called move right simple is just going to, when it's activated, increase the calling object's X value. So I'm going to save that. And now I'm going to go down to my input editor. This is going to have to happen when I'm holding it down because I want it to continue to increase as long as that's down. So it's not just when I press it, it's when it's held. So I'm going to go to main game when the right arrow is held, when I'm holding down the right D-pad. Now I do want this attached to an object. I want it to attach to player 1. I want to run move right simple, and I'm going to add it. And so you can sort of read this like a sentence. When I hold right, the player is going to call movement script, and we know what that's going to do. That's going to change its X value. So real quick, let's render this out, open it in FCUX. And it's that simple. So now he's moving to the right. Now, I can't make a move to the left. I haven't told him to move left yet. He also didn't animate. He doesn't change direction to left when I press left. So there's still a lot of things that I have to do to make this work and actually feel like game movement should. Let's go ahead and do them. Real simple, I'm going to go to my code scripts, and I'm also going to load in move left. Simple. Take a look at that. Again, nothing there. So you can, if I increase X to move right, you can probably figure out I'm going to decrease object X high X. So now the X value that belongs to whatever object is calling this script is going to decrease. Save that, and let's apply it. Input editor. When I'm in the main game state and I am holding left, I want the player to call the left movement script. And you can read it like a sentence. So these are all the inputs that are active right now. I'm going to export and test one more time and then open it in FCUX. Press start. And then he should be able to move back and forth, left and right. Now again, he doesn't face left and right. He's not animating. So this isn't perfect yet. Let's now add all of that and explain how that can work. And once again, this is a disclaimer. If you're not somebody who wants to learn how to code, don't stress. A lot of these functions are going to be available to you, and you can always add more with other people who write scripts as long as they're conforming with whatever else you have in your game engine. So don't freak out. But the great thing is it's this simple to actually write your own custom assembly. So what we're hoping is that this gives you the confidence to start writing some assembly and getting into it at that level and come up with things that we never even dreamed of, that we never even thought of. Okay, let's modify these scripts to do the other things that we want them to do. First of all, every object has a variable called direction, and they can either be left, right, up, down, and all the diagonals. I'm going to load right, and I'm going to store that into object direction X. So now the binary value that's associated with this label right here is going to get tossed into the variable for this object called direction. And the engine that's underneath knows what to do with this information to draw the sprite facing the right direction. The other thing that I want him to do is I want him to animate. Now, in order to get him to animate, what I have to do is, if I look at this object, I need to get him from action step 0, and I need to jump to action step 1. Action step 1 is his running animation, and it's got an animation speed of 8. So if I want him standing still, he's got to be action step 0. If I want him running, he's got to be action step 1. So I'm going to go back to my simple movement, and I'm going to load 1 and store it into object action step. That'll make him jump to that next action step, which correlates to him running. I'm going to do the same thing. I'm going to save that. Do the same thing to move left simple. I'm going to have it load left, store it to object direction X, and I'm going to load 1. I'm going to store that to object action step. The only thing that's wrong right now is we've told it to change to object action step, but we haven't told it when to change back. We haven't told it when to stand still. So we're going to expect that, yes, he's going to change direction left and right, and he's going to move left and right depending on the inputs. But he's going to change that first time to running animation, and he's never going to change back. That's what we expect right now. And what's great is you don't have to get back into the input editor at this point. All the scripts are still wired up. All the scripts are still in the same places they were. All we've been doing, I forgot to save that. Let me write that again. Sorry. All the scripts are still exactly wired up the same way. So any modifications we do, we don't have to go back into the input editor and change. We can just change the script. So I'm sorry. Let me load left. Forgot to save. Store this into object direction X. Load 1. Store that into object action step. Okay, save. All right, so now let's test that. And now we'll get a nice animated Sydney Hunter. But he doesn't stop. When do I want him to stop? Well, for this, I'll just say when I let go of the right, he goes to idle. And if I let go of the left, he goes to idle. In reality, I might have to check some other things. I might have to check to see, is he in the air? Then he shouldn't be idle. He should stay falling. Is he hurt? Then he should show the hurt graphic, that kind of thing. But for right now, I'm just going to make him run, and when I let go of the key, he's going to stop. Okay, no problem. I actually made a quick script that all it does is it changes his action step back to 0, and that's called change to idle. We'll add that. I don't have to make any changes to that one. All that does is it loads 0 and stores that into the action step. So it changes his action back to 0, which was no animation and that static frame, that single frame of animation. So input editor, when I release the right button and I'm in the main game, my player is going to change back to idle. And when I release the left key in the main game, my player is going to change to idle. All right, test this one more time, and we should have him running back and forth. And there he is. And you can see down here when I'm pressing it and when he's changing states. And now I've got him running back and forth and stopping when I let go of the key. Now, you might want, you probably have seen in our last sets of tutorials and things when we've been dealing with objects, there's acceleration, so we can make him speed up like he's on ice, or make it a little bit more floaty, or a little bit more like Mario, where if it feels like you've got inertia. This, though, doesn't do that. This just literally increases the X value. That's all it does. If I wanted to do that, what I'm dealing with is a variable called object movement byte. Basically, with object movement byte, when it's turned on, it handles movement depending on the rest of the bits in that byte. Instead of just straight up increasing the X, you turn on the movement byte and it runs through this script, which handles things like collision detection with all the background and things like that. So we can actually do that pretty easy. We can modify this to do that, and that's by doing this. Load. Storing it into object movement byte X. This, and I can put a comment in here, turns on right movement. That's what this does right here. Now, I don't expect you to remember this, and in fact, we're working on macros that handle this. And a macro is just a single line of code that you can write that'll remember this stuff for you, but you can, it's easier to read without sort of looking at the byte data. I'll show you. So there's a macro right here called start moving, and it does what I just did over there essentially. If I write start moving, and then it looks to what direction? Start moving, and here's the argument that I'm looking for. Move right. So if I write start moving, move right, it will start moving right. So if let me do that. Instead of writing this, I'm going to write start moving, start moving, move right. This turns on the right movement right here. I can save that. And my move left simple, instead of doing this, it's going to start moving, move left. I'm going to save that. I still want the direction to change, and I still want it to start animating, so I'm going to keep that. All I'm doing is, instead of literally moving the X value by some arbitrary number, I am now activating the acceleration and the max speed and the collision detection and all those things that I have in the physics routine. So I'm going to save that. And lastly, change to idle. When I let go of those keys, what I need to do is I need to stop. So I'm going to load 0, 0 and store that into object movement byte X. And now let's test that real quick. So now he's got a little bit of acceleration and deceleration. It's hard to see, but now I'm definitely colliding. To make that even more pronounced, let's change his acceleration speed to a really slow acceleration speed, but a really fast speed. So what I can do is I can go to player and look at his animation info. And now that I'm using our physics engine, I can set his acceleration speed to 5 and his speed to 18 or something like this. And now when I test it, it'll take a long time for him to speed up instead of just moving that 1 pixel at a time. Check it. So now I'm making use of that physics engine. And you saw how easy it was for me to start making changes and how I could do it with just a few lines of code. So that's the basics of how our, Sydney Hunter. That's the basics of how our input manager is going to work. And the interface may change the way that it looks, and there's a lot of other ideas, but you can see how people are asking, oh, can you make a 2-player game? And it's like, yes, you can. And you just have to start plotting out what these codes would be for 1 player versus the second player in a 2-player game, and how the camera actually works and things like that. There's more to think about it than just the concept of two-player game, yeah, that's not that hard, and the objects are already meant to work with the collision and things like that. If you put the right codes in, I could just as easily have had a player 2 and a player 1 and a player 2 target, and told, you know, if I'm on the second controller and I press left, you could probably make a game where both controllers are used to control one object, or that 2 controllers are used to control 4 different objects, just by sort of manipulating the input and what of these inputs handle which scripts. So I know that was kind of long, and I know we got into some code, and some of you are kind of gun shy about getting into the code. Don't freak out. There's going to be, if you look, I mean, these are just the code scripts that are there now, and there's going to be even more to choose from, you know, as time goes on. And obviously, when you get a module, it'll preload all the ones that are relevant and all the inputs that are relevant, and then it'll just be a matter of you going in and editing them. But I really wanted to show today how it worked and how you as a user could learn to manipulate it and even start writing your own assembly code without having to start all the way from the bottom, being able to see that sort of instant feedback of whether or not what you wrote worked and how it changed things and stuff like that. So I hope you enjoyed this. Can't wait to move on to the next video and show you what's next. We're working very hard, and we really appreciate you guys' excitement, your enthusiasm, your patience. Yeah, we'll catch up with you in another update, hopefully in about a week. Thanks.
If you want to see more videos about NES Maker and how to create your own NES games, please subscribe to our YouTube channel and help us get the word out further by sharing this video on social media.